So in question 2, we are given a experiment. We are told a student hangs a spring of known spring constant K, of unknown spring constant K, vertically by attaching it to a stand, and then we can attach small cylinders to the end of it. And we'll only have a variety of cylinders with unknown masses, a stopwatch, and a digital scale. We need to design an experimental procedure that we could use to determine the spring constant K of the spring. So we need to fill out this table provided. So firstly, equipment for the first line, equipment for measurement, stopwatch. Well, what we're going to be measure the quantity is simply going to be the period of oscillation. So this is going to be the time period. We can symbolize this with like a capital T. With a digital scale, we will be measuring the mass of a cylinder. Like this, and we can represent this with a small m, and that's basically it. And yeah, so these are the two things that we will need to measure. And for the procedure, we need to describe the main steps we need to take. So the idea of this experiment is that we take a cylinder, we measure its mass, so we know how heavy it is, we place it on the end of the spring, we make it oscillate, we measure the period of oscillation, and then we can use the formula for the period of a mass spring system to calculate the spring constant of the spring. We also need to state a way to reduce uncertainty, and to reduce experimental uncertainty, there are multiple ways we could do this. For example, using a bunch of masses and then finding an average result, or we could also do multiple trials with a single mass so that we reduce our experimental uncertainty. Or we could also, instead of just measuring one oscillation, we could measure 10 oscillations, for example, or 20 oscillations, and we could average it out for the time period so that we get a more precise value for a single oscillation. So for the procedure, we could say first step is to record the mass of a cylinder. And then well, we can hang it on the spring. Hang on the spring. And then displace it by some distance so it starts going up and down, oscillating. And then we can measure time for, let's say, 10 oscillations. And then we can repeat for more masses. So this is the idea that we need to use here. These are the key steps to this experiment.